There is a quiet change that happens inside the body, so gradual that most people do not notice it until years have passed. It begins with small things. Getting up from a low chair requires a brief moment of preparation that was not needed before. Carrying groceries from the car to the kitchen leaves you slightly more tired than it once did. A walk that used to feel effortless now requires a certain amount of conscious decision. These small shifts are easy to dismiss as simply aging, as what everyone must expect as the years accumulate. But this assumption deserves examination. Because what if some of what we call aging is not the inevitable passage of time, but something else entirely? What if the body is not merely wearing out, but responding to conditions it never expected to encounter? The way we live now is so different from the way humans have lived for almost all of our existence that the body has not had time to adapt. It is still expecting something else. It is still waiting for movements and rhythms that modern life no longer provides. And in that gap between what the body expects and what it receives, much of what we accept as normal aging may actually be something more reversible than we realize. This is not about reversing time or chasing youth. It is about understanding what the body actually needs and giving it those things in a calm, sustainable way. The most powerful tool for this may already be within your reach, requiring nothing more than the willingness to use it. You are listening to the Longevity Library, where we archive the wisdom of healthy aging. The unhurried life, a calm examination of movement, time, and human longevity. There is a question worth considering, not because it demands an immediate answer, but because it invites us to reflect on something we rarely examine directly. The question is this: what did the human body expect when it was being designed, if we may use that word loosely, over hundreds of thousands of years of slow adaptation? What conditions did it prepare for? What daily experiences did it assume would always be present? These are not small questions. They touch on something fundamental about health and the passage of time. Because the body, for all its remarkable adaptability, was shaped by circumstances that no longer exist for most of us. And in the gap between what the body expected and what modern life provides, many of the common difficulties of aging may find their origin. Consider the matter of movement. The body assumes movement. It expects to be in motion for much of the day, not because movement is exercise in the modern sense, but because movement was simply how life worked. Food required moving to find it. Water required moving to reach it. Safety required moving to maintain it. The body built its entire infrastructure, its circulation, its metabolism, its very structure, around the assumption that movement would be the constant background of existence. Now consider the modern condition. For a significant portion of the population, the background of existence is not movement, but its opposite. Sitting has become the default position. We sit to work, sit to travel, sit to eat, sit to be entertained. The body finds itself in circumstances it never prepared for, doing something it never expected to do for such extended periods. And it responds in ways that we have come to accept as normal, but may be anything but. This examination is not about alarm. It is not about fear or dramatic change. It is about understanding, gently and clearly, what the body needs and why, and then considering how we might restore, in a calm and sustainable way, some of what has been lost in the transition to modern life. Part 1. The body in time. To understand what the body needs as it moves through the years, it helps to understand something about time itself, not clock time, but biological time. The body keeps its own schedule, follows its own rhythms, responds to patterns that operate beneath the level of conscious awareness. Every cell in the body contains tiny timekeepers, molecular structures that rise and fall in regular cycles over approximately 24 hours. These circadian rhythms govern when we feel alert and when we feel sleepy, when hormones are released and when they are suppressed, when the body is primed for activity and when it prepares for rest. These rhythms are not optional. They are not suggestions. They are the fundamental architecture of biological life. Light is the primary signal that sets these rhythms. When light enters the eyes, particularly the specific wavelengths present in natural daylight, it triggers a cascade of signals that travel to the master clock in the brain. This clock then synchronizes all the other clocks throughout the body. Morning light tells every cell that the active phase has begun. Evening darkness tells them that rest approaches. This system worked flawlessly for the entirety of human existence until very recently. People woke with the sun, or close to it. They spent their days exposed to the full spectrum of natural light. As the sun set, the light spectrum shifted, and the body began preparing for sleep. Melatonin rose. Temperature dropped. Sleep came. Now the signals are scrambled. We spend most of our days indoors, under artificial light that provides only a narrow slice of the full spectrum. In the evening, we expose ourselves to blue-rich light that tells the brain it is still midday. The body's timekeepers receive conflicting information. They do their best to adapt, but the adaptation is imperfect. Sleep becomes more difficult. Energy becomes less predictable. The careful orchestration of biological processes begins to show small cracks. Morning walks address this problem directly. When you step outside in the early light, even on an overcast day, your eyes receive the signal they have been waiting for. The light enters. The clock is set, and the entire system aligns. This is not about getting exercise, though that happens too. It is about timekeeping. It is about telling every cell in the body that the day has begun and it is time to be awake. The effects ripple through the entire day and into the night. People who get morning light exposure tend to fall asleep more easily in the evening and sleep more deeply once they do. Their energy during the day follows a more natural curve, rising in the morning, dipping slightly in the afternoon, and declining gently toward evening. The body remembers what it is supposed to do. This is one example of a larger principle that will appear throughout this examination. Small, consistent practices that align with the body's expectations often produce effects far out of proportion to their apparent simplicity. The body was not designed to be managed and manipulated. It was designed to be supported. And support often looks like simply providing the conditions it already knows how to use. Part 2. The expectation of movement. If light is the primary signal for biological time, movement may be the primary signal for biological function. The body expects to move. Every system within it was built around that expectation. Consider the cardiovascular system. The heart is a muscle, and like all muscles, it responds to demand. When the body moves, the muscles require more oxygen. The heart responds by beating more forcefully and efficiently, strengthening itself in the process. Blood vessels expand and contract to direct flow where it is needed. The entire system maintains its flexibility and responsiveness through use. When the body sits for long periods, the cardiovascular system receives a different message. Demand is low. The heart can ease its efforts. Vessels can lose some of their elasticity. The system does not fail, it adapts. But it adapts to the conditions it is given. And the conditions it is given may not be the conditions that support long-term function. The lymphatic system provides an even clearer example. Unlike the cardiovascular system, which has the heart to pump blood, the lymphatic system has no central pump. It depends entirely on movement. Muscles contracting, joints bending, the body changing position. These actions create the pressure changes that move lymph through its vessels. Lymph carries immune cells and removes cellular waste. When movement stops, lymph slows. Waste products accumulate. Immune surveillance diminishes. This is not a theory. It is simple mechanics. The system was designed with the assumption that movement would provide the pumping action. When movement is removed, the system cannot perform as intended. The metabolic effects follow similar logic. Muscles are not just for moving the body. They are metabolic organs in their own right. They consume glucose, store energy, and signal to the rest of the body about energy availability. When muscles are used regularly, they become more efficient at pulling glucose from the bloodstream. When they are idle, that capacity diminishes. This becomes particularly relevant after meals. When food is eaten, particularly food containing carbohydrates, blood glucose rises. The body releases insulin to move that glucose into cells. Muscles are the primary destination, but muscles require activation to be fully receptive. A muscle that has been sitting all day is less responsive than one that has been used. The same meal produces a higher blood sugar spike in a sedentary body than in an active one. Walking after meals addresses this directly. The muscles of the legs, activated by walking, become more receptive to glucose. They pull it from the bloodstream, moderating the rise in blood sugar. Research has observed reductions in the blood sugar response of 40 to 50% following a walk, compared to remaining seated. This is not about extreme measures. It is about working with the body's design rather than against it. The cumulative effect of these small adjustments over years may be significant. Blood sugar spikes, even in people without diabetes, produce inflammatory responses and oxidative stress. Repeated day after day, year after year, they contribute to the gradual changes we associate with aging. Moderating them through simple movement after meals may be one of the most practical strategies available for supporting long-term metabolic health. Part 3. The weight-bearing life. The skeleton tells its own story about the expectations of the body. Bones are living tissue, constantly being broken down and rebuilt. Cells called osteoblasts build new bone. Cells called osteoclasts break down old bone. The balance between them determines bone density. This balance is influenced by many factors: hormones, nutrition, genetics, but one of the most important is mechanical load. Bone builds in response to the forces placed upon it. When you walk, run, or lift, the bones of your legs and spine experience stress. They respond by becoming stronger, adding density where it is needed. When you sit for long periods, the bones experience less stress. The signal to maintain density weakens. Bone breakdown may begin to outpace bone building. Over years, this gradual shift can lead to lower bone density and increased fracture risk. This process is slow and invisible. You cannot feel your bones becoming less dense. You cannot tell that the balance has shifted until something breaks. But the progression is steady, and the factors that influence it are cumulative. The movement choices made in middle age affect bone health in later decades. For women, this becomes particularly relevant after menopause. Estrogen plays a protective role in bone health. And when estrogen levels decline, bone loss accelerates. The mechanical loading from weight-bearing activity becomes even more important as a counterbalance to this hormonal shift. Walking, because it is weight-bearing and can be sustained indefinitely, provides a reliable stimulus for bone maintenance throughout life. The same principle applies to muscle. Sarcopenia, the gradual loss of muscle mass with age, is often presented as inevitable. But the degree of loss varies enormously between individuals. Those who remain active throughout life retain far more muscle mass and strength than those who become sedentary. The difference is not genetic luck. It is the cumulative effect of decades of use versus disuse. Muscle requires stimulation to be maintained. The signal for muscle to keep its mass is simply being used. When muscles are regularly activated, they receive the message that they are needed and should be preserved. When they are seldom used, the body treats them as expendable resources. redirecting energy and protein elsewhere. Walking alone will not build large muscles, but it will help maintain the muscles you have. The legs, in particular, contain some of the largest muscles in the body. Keeping them active through daily walking preserves not just strength, but also metabolic capacity. Muscle tissue is metabolically active, meaning it burns calories even at rest. Preserving muscle mass helps maintain metabolic rate, which otherwise tends to decline with age. Part 4. The thinking body. The connection between movement and cognition may be less obvious than the connection between movement and muscle, but it is equally real. The brain is not isolated from the rest of the body. It is nourished by the same blood, influenced by the same hormones, affected by the same patterns of use and disuse. Blood flow to the brain increases during physical activity. This is partly because overall circulation increases, and partly because the brain itself becomes more active during movement, coordinating balance, navigation, and the countless unconscious adjustments required to walk smoothly through the world. More blood flow means more oxygen and nutrients delivered to brain tissue, and more efficient removal of waste products. The brain also produces neurochemicals in response to movement. Brain-derived neurotrophic factor, sometimes called BDNF, supports the survival of existing neurons and encourages the growth of new connections. Levels of BDNF rise with aerobic activity and fall with inactivity. This protein appears to play a protective role in brain health, and its production is one mechanism through which physical activity supports cognitive function. Attention and memory show measurable improvements following walks, particularly walks in natural settings. Research has observed improvements of around 20% in attention and memory performance immediately after people spend time walking in nature. The effect does not require strenuous effort or long duration. A moderate walk of 30 to 45 minutes appears sufficient. Why nature specifically? Several factors may contribute. Natural environments tend to be less demanding of directed attention than urban environments. They provide a kind of gentle fascination that allows the brain's attentional systems to rest and recover. The visual patterns of nature, the fractal shapes of trees, the movement of leaves, the play of light, appear to engage the brain in ways that are restorative rather than taxing. Natural settings also tend to have lower levels of noise and air pollution, both of which affect cognitive function, and time in nature is often associated with lower stress levels, as measured by cortisol and other stress markers. The combination of gentle movement, restorative environment, and stress reduction may create conditions particularly favorable to cognitive function. The effects are not permanent from a single walk, but they accumulate over time. People who regularly walk in natural settings tend to show better cognitive function than those who do not, and the difference becomes more pronounced with age. The protective association between physical activity and reduced dementia risk is one of the most consistent findings in aging research. Part 5. The eating-moving connection. There is a pattern in traditional cultures that has largely disappeared from modern life. Movement after meals. In many societies throughout history, eating was followed by walking, returning to work, traveling to the next location, attending to daily tasks. The meal was not the end of movement, but an interruption within it. Modern meals are different. For many people, eating is followed by sitting at the table, then on the couch, then in front of a screen. The body goes from fuel intake to complete rest, and the metabolic consequences of this pattern are worth examining. When food enters the digestive system, it begins to be broken down into its components. Carbohydrates become sugars, primarily glucose. Proteins become amino acids. Fats become fatty acids. These nutrients enter the bloodstream, and blood levels rise. The body responds by releasing hormones that direct these nutrients into cells where they can be used or stored. Glucose is particularly time-sensitive. High levels in the blood can damage tissues over time, so the body works to bring glucose down quickly. Insulin signals cells to take up glucose. The liver and muscles store what they can. The process normally takes 1 to 3 hours, depending on the meal and the individual. Movement during this period changes the equation. Active muscles become glucose sponges. They increase their expression of glucose transporters, proteins on the cell surface that pull glucose from the blood. They do not need insulin to do this. Muscle contraction itself triggers glucose uptake through a separate pathway. The result is that glucose is cleared from the blood more quickly and more efficiently. Walking after a meal takes advantage of this mechanism. The muscles most involved in walking, the large muscles of the legs, are precisely the ones with the greatest capacity for glucose uptake. A 20-minute walk after dinner can significantly reduce the peak blood sugar level and shorten the time blood sugar remains elevated. This matters not only for people with diabetes, but for everyone. Repeated blood sugar spikes create oxidative stress and contribute to the formation of advanced glycation end products, compounds that damage proteins and contribute to aging-related changes. Moderating these spikes through simple post-meal movement may be one of the most practical anti-aging strategies available. The effect is specific to the timing. A walk in the middle of the day provides many benefits, but it does not have the same impact on post-meal blood sugar as a walk immediately after eating. The glucose transporters activated by walking return to baseline after a few hours. To catch the glucose as it enters the bloodstream, the movement needs to happen while glucose is rising. This does not mean every meal requires a walk. For many people, dinner is the largest meal and the one most likely to be followed by sitting. Starting with an after-dinner walk may be the most practical entry point. If that becomes habitual, adding walks after other meals provides additional benefit. Part 6. The cumulative perspective. One of the challenges in thinking about health and aging is that the effects we care about most are slow and cumulative. No single walk will transform your health. No single meal will determine your metabolic future. The body responds to patterns, not events. It is shaped by what you do consistently over years and decades, not by occasional efforts, however heroic. This can feel discouraging, but it is actually liberating. It means you do not need to be perfect. You do not need to follow an ideal program or meet some external standard. You simply need to establish patterns that you can maintain, patterns that align with the body's expectations, patterns that support rather than fight against your own biology. Walking every day is such a pattern. It is not dramatic. It is not intense. It does not produce immediate visible results. But over months and years, the cumulative effect of daily movement is profound. The cardiovascular system remains more flexible. The metabolic system remains more responsive. The musculoskeletal system remains stronger. The cognitive system remains sharper. The same principle applies to the timing of movement. Walking after meals, when you can manage it, provides specific benefits that accumulate with each walk. Walking in the morning light provides circadian signals that improve sleep and energy. None of these individual walks matters enormously, but hundreds of walks over years matter a great deal. This cumulative perspective also helps explain why the longest-lived populations around the world share certain characteristics. They do not typically exercise in the modern sense. They do not go to gyms or follow workout programs. They simply remain active as part of daily life. They garden, walk, tend animals, do household tasks, visit neighbors. Movement is woven into the fabric of existence rather than being a separate activity that must be scheduled and completed. This kind of movement is sustainable because it is not a burden. It does not require motivation or willpower. It is simply what you do as you move through the day. The body stays in the condition that movement maintains, and the movement itself remains possible because the body stays in condition. It is a virtuous cycle that can continue for decades. Part 7. The question of intensity. There is a persistent assumption in modern fitness culture that more is better and harder is better still. If walking is good, running must be better. If 30 minutes is good, 60 minutes must be better. This logic has some truth, but also some significant limitations. High-intensity exercise provides specific benefits that walking does not. It builds greater cardiovascular capacity, stimulates more muscle growth, and may produce different hormonal responses. For people who can safely perform higher-intensity activities, incorporating them into a weekly routine can be valuable. But high-intensity exercise also has costs. It produces more stress on joints and connective tissues. It requires more recovery time. It carries higher risk of injury. And perhaps most importantly, it is harder to sustain over decades. Many people who begin high-intensity exercise programs in middle age find themselves unable to continue them into later decades. Injuries accumulate. Joints complain. Motivation wanes. Walking has none of these limitations. It can be done safely by nearly everyone, at nearly any age, with nearly any fitness level. It produces minimal joint stress and carries very low injury risk. It requires no recovery time. You can walk every day without needing days off. And it remains accessible well into the 9th and 10th decades of life. This sustainability matters enormously from a long-term perspective. An activity you can do every day for 60 years produces more cumulative benefit than an activity you do intensely for 5 years and then abandon. The best exercise is not necessarily the one that produces the most benefit per minute. It is the one you will actually do, consistently, for the rest of your life. This is not an argument against higher intensity activities. For those who enjoy them and can do them safely, they provide valuable additional benefits. But they should be seen as supplements to a foundation of daily movement, not replacements for it. The foundation comes first. Without it, the occasional intense workout cannot compensate for hours of daily sitting. Part 8. The social body. Humans are social animals. This is not a sentimental observation, but a biological fact. The body responds to social connection with measurable changes in stress hormones, immune function, and even gene expression. Isolation produces the opposite effects. Walking can serve social functions that support overall health. Walking with a spouse, friend, or group provides the movement benefits while also meeting social needs. Conversation during a walk may be different from conversation in other settings, less pressured, more reflective, paced by the rhythm of steps rather than the demands of face-to-face interaction. For those who live alone, walking groups or walking partners can provide regular social contact that might otherwise be missing. The commitment to meet someone for a walk creates accountability that helps maintain the habit. The walk itself becomes an event to look forward to rather than a task to complete. Even walking without company can provide a kind of social connection through exposure to community. Walking through a neighborhood, seeing other people, exchanging greetings, observing daily life. These small interactions contribute to a sense of belonging and connection. They counter the isolation that can so easily develop in modern life. The social dimension of walking may be particularly important for older adults who face higher risks of social isolation. Retirement, loss of spouse, children moving away, friends becoming less mobile. All of these can shrink the social world. Walking provides a reason to be out in the community, a way to maintain connections, a structure for social interaction that does not depend on formal arrangements. Part 9. The environmental context. The environment in which you walk matters. walking through a city, along a busy road, through a quiet neighborhood, or in a natural setting. Each provides different experiences and different effects on the body and mind. Natural environments appear to have particular benefits. Time in green spaces is associated with lower stress markers, improved mood, better cognitive function, and even reduced mortality in some studies. The effect is consistent across different populations and different types of natural settings. Trees, water, open sky, these elements seem to affect us at a level beneath conscious awareness. Several mechanisms may explain this. Natural environments tend to have lower noise levels, which reduces stress. They often have cleaner air, which benefits respiratory and cardiovascular health. They provide visual patterns that are inherently restful to the visual system. And they may trigger evolutionary responses, a sense of safety and resource availability that calms the nervous system. Urban environments, by contrast, place different demands on attention and stress systems. Traffic, crowds, noise, and visual complexity require constant processing and vigilance. These demands are subtle. You may not notice them consciously, but they accumulate over time. A walk through a busy city provides movement benefits, but may not provide the same restorative effects as a walk through a park. For those without easy access to natural areas, even small amounts of green can help. Tree-lined streets, community gardens, cemetery paths, botanical gardens, any place with vegetation and reduced human commotion provides some of the benefit. The goal is not perfection, but improvement. A walk with some green is better than a walk with none. Seasonal and weather considerations also matter. Walking in different conditions provides different experiences and challenges. Rain, snow, heat, cold, each requires adaptation but also offers its own pleasures. The changing seasons provide variety that keeps walking interesting over years and decades. Learning to walk comfortably in different conditions expands the possibilities for maintaining the habit year-round. Part 10. The practical integration. Knowing that walking is beneficial is different from actually walking. The gap between knowledge and behavior is where good intentions go to die. Bridging that gap requires practical strategies that work with human psychology rather than against it. Start with what is already there. Look at your existing daily routine and identify places where walking could be inserted without requiring major changes. Could you park farther from the store entrance? Could you take the stairs instead of the elevator? Could you walk to a nearby destination instead of driving? Could you walk while talking on the phone? These small insertions add up without feeling like a separate task. Consider the after-dinner walk as a default. After eating, instead of moving to the couch, move to the door. Even 10 minutes provides benefit. Even 5 minutes is better than nothing. The walk does not need to be long to be worthwhile. Short walks after meals can be easier to sustain than a single long walk at another time of day. Morning walks deserve special attention because of their circadian effects. If possible, step outside within an hour of waking. The light exposure sets your biological clock for the day. The movement gently awakens the body. The combination prepares you for the day ahead in ways that no indoor activity can match. For those with mobility limitations, adaptations are available. Walking aids, when needed, allow continued movement. Level surfaces reduce difficulty. Shorter walks with rest periods provide benefit without overexertion. Walking in place, marching while holding a counter, or using a stationary device can provide movement when outdoor walking is not possible. The principle is to move as you are able, within your current capabilities, without comparison to others or to your younger self. Accountability can be helpful, but should be gentle. A walking partner provides natural accountability through social commitment. A simple log or calendar can provide satisfaction from tracking consistency without becoming obsessive. The goal is to make walking feel like part of life, not another obligation. Part 11. The question of time. Time is the resource that feels most scarce. Yet walking requires relatively little of it compared to the benefits it provides. 30 minutes per day represents about 2% of waking hours. Spread across a lifetime, that small investment produces enormous cumulative returns. But time must be considered not only in quantity, but in quality. A rushed walk, constantly checking the clock, does not provide the same experience as an unhurried one. The benefits of walking come partly from the movement itself, but also from the mental state it produces, the gentle focus, the rhythmic attention, the break from constant doing. This suggests that walking is best approached not as something to get through, but as something to inhabit. The walk is not a means to an end, but an end in itself. It is time spent in the body, in the world, moving through space and noticing what there is to notice. This perspective makes walking sustainable because it makes walking satisfying. For those who find walking boring, consider what you bring to the walk. A walking practice can include observation, noticing changes in plants, animals, weather, people. It can include listening to birds, to wind, to the sounds of the neighborhood. It can include thinking, letting the mind wander where it will, following thoughts without needing to direct them. The walk becomes a space for whatever arises, not a task to be completed. Technology can support or interfere with this. Music or podcasts can make walking more engaging, but can also distract from the experience of walking itself. Experiment with different approaches. Some walks with stimulation, some without. Notice how each feels. Let your own experience guide your choices. Part 12. The long view. The oldest old, those who reach 95, 100, and beyond, did not get there by following a program. They got there by living, day after day, in bodies that remained capable of movement. They walked to the store, to the garden, to the neighbor's house. They moved through their days doing what needed to be done. Movement was not separate from life. It was life. This is not a prescription to abandon modern convenience and return to some imagined past. It is an invitation to notice what has been lost and consider whether some of it might be worth restoring. The body remembers what it was made for. It responds when given the conditions it expects. Walking is not a cure. It is not a guarantee. It is simply a practice, available to nearly everyone, that aligns with how the body was designed to function. It supports circulation, metabolism, structure, and cognition. It provides light exposure, social connection, and time in the world. It can be done anywhere, at any age, with any level of ability. It costs nothing and requires nothing but the willingness to step outside and move. The research supports this. Population studies show associations between daily movement and longer, healthier lives. Physiological studies show mechanisms through which movement produces its effects. Clinical studies show improvements in specific outcomes with walking interventions. The evidence is consistent across many different types of investigation, but the evidence is not the point. The point is the experience of living in a body that moves, that feels capable, that can do what you ask of it. The point is the quiet satisfaction of a daily walk, the noticing of small changes, the rhythm of steps that carries you through the day and through the years. The point is that walking, simple and ordinary, connects you to something fundamental about being human. Conclusion. There is a tendency in discussions of health and aging to look for the exceptional, the special diet, the breakthrough supplement, the revolutionary exercise protocol. These things have their place, but they can distract from what is most basic. The foundation of long-term health is not exceptional. It is ordinary. It is the accumulated effect of countless small decisions, repeated day after day, year after year. Walking is the most ordinary activity there is. It requires no special skill, no equipment, no preparation. It is the first voluntary movement we learn as infants and the last we are able to maintain as we age. It has been part of human life for the entire existence of the species. And it may be, for all its simplicity, one of the most powerful things we can do to support our own long-term well-being. The evidence for this is strong, but does not need to be the reason you walk. You can walk because it feels good, because it clears your mind, because it gets you outside, because it gives you time to think, because it connects you to your neighborhood, because it is something you can do with a friend, because it is simply what you do after dinner. The reasons do not matter. Only the walking matters. Start where you are. Walk as you are able. Add a few minutes when you can. Walk after meals when possible. Walk in the morning light when possible. Walk with someone when possible. Walk in nature when possible. But mostly, just walk. The body knows what to do with it. The years will take care of themselves. The body remembers what it was made for. It remembers movement, light, the rhythm of steps carried through years and decades. It remembers because these things are not additions to human life, but the very fabric of it. The oldest among us did not reach advanced age through complicated protocols or extraordinary measures. They reached it by living each day in bodies that remained capable of movement, by walking to the garden and the market and the neighbor's home, by doing what needed to be done, and in doing so giving their bodies the signals they required. The single most important takeaway from everything we have explored is this: the foundation of long-term health is not exceptional. It is ordinary. It is the accumulated effect of countless small decisions, repeated day after day, year after year. If this reflection has stirred something in you, if it has prompted thoughts about your own relationship with movement and time, we would be honored to hear your impressions in the comments. And if you would like to continue exploring the wisdom of healthy aging, we invite you to browse other recordings in this library and to subscribe so that new reflections find their way to you. This is the Longevity Library. Listen, learn, and live longer.